Good afternoon, everybody. I'd like to welcome you all to the Weedon Island Cultural and Natural History Center, and we're so pleased to welcome you here for our program. I'm Liz Childress. I am the center's supervisor, and again, we're delighted to have you here for the Origins of Tampa Bay. This is a special edition of the Florida Conversations program series from our partner at the Tampa Bay History Center, and we want to thank our partners at the Tampa Bay History Center for helping us put this on. And we're going to learn a little bit about the history of Tampa Bay from a paleoenvironment and an indigenous and a historical perspective. We're going to hear talks from Dr. Tom McPluckin and Dr. Kendall Jackson, and soon to be Dr. Jamie Rogers. And I'd like to welcome our Zoom audience. For those of you who are joining us on Zoom, please put your questions, if you've got any, in the question and answer session, and we will address them at the end of the program. And for those of you in the audience, we will have a short question and answer session when we are finished. So with that being said, I think we're ready to get started. Who's going first?
Me.
All right, take it away, Kendall. Thank you.
Thank you. Hi, all. Thanks for coming out. What a great turnout. This is excellent. So, slide advancer, perfect. All right. My name's Kendall. I'm an archaeologist. Specifically, what I do you could call geoarchaeology. I'm sort of in between geology, the study of the earth, and archaeology, study of past peoples. So I'm going to kick us off with some geological prologue, if you will, but from an archaeological perspective. So I'm going to start way back, about 200 million years ago. Everyone can conceptualize that amount of time right away, right? No problem. But Florida is a fascinating place to study the sort of deep time, ancient past. So we're going to start way back. Let me see if I can get this to advance. Or I hit this. That'll work. All right. Thanks. So this is a current map model of North America. So nothing crazy here, just present day. I just like to show this as a reference. Thank you, Liz. Because, it's good to know where we're at. And the statement the thing I want you to start with, your perspective, is that Florida, in geological terms, was born of the sea, right? And Florida's geology and history is sort of always at the whim of the oceans, right? So if we go back about 50 million years, long time ago, Florida, you can see here in this model, is submerged in the ocean. Sea levels were something like 120 meters above present. And Florida at that time was not land. Florida was submerged beneath a shallow, clear-watered tropical sea, right? And that environment creates carbonates, right? Coral reefs, carbonate mud flats, all kinds of carbonate-producing environments that build up over time and created this large platform you can see here on the map in that light blue. So this carbonate building process went on for long enough that this carbonate rock platform, preserved now beneath the state of Florida, reaches something like 6 kilometers in thickness. That's just a ridiculous amount of deposition over time. It's even thicker in the Bahamas. It's something like 14 kilometers in the Bahamas bank. Now, you can see in this graph on the right some just climate and sea level trends. You don't have to read that tiny text too much, but you can see sea level was considerably higher. The Earth is much warmer. And this is just sort of a drawing of carbonate production on the Florida platform, bordered by reefs. And what enabled this environment to sort of build up over time was that there was a large seaway separating what we think of as the Florida Peninsula and where Georgia is now, right? And the currents running through that seaway swept away all the sediments that were eroding off the Appalachians, running down into the ocean. It swept those sediments away, and it kept the area where Florida is now a clear-watered tropical sea where those carbonates could continue to build up. Now, if we fast forward a little bit to about 30 million years ago, we have that big seaway, the Swanee Channel or Swanee Straits, starts to get filled in with sediment, right? And eventually, it's basically blocked off, right? And then there's a pathway for all those sediments eroding from the Appalachians to make their way down onto the Florida carbonate platform, sort of creating the first dry land in what we think of as Florida now, which you can see drawn here. Right? Sea level's still way higher than present. Now, all this sediment making its way down, it's developing coastal landforms, right? We might think of it as analogous to like beach and barrier island systems or things like that, winnowing all that sediment and leaving only the quartz sand, which is why our beaches are the best in the world, right? I'll just go ahead and say that. We have all that winnowed, pure quartz sand, right? So if you, during this time, we have the formation of some of the highest ridges in the state, if you go towards the center. Now, as we get much, much closer to present into the Pleistocene epoch, a couple million years ago, we enter into these major, relatively rapid, geologically speaking, major swings in sea level and climate, where we have just really quite high sea level and then drops in much, much lower than present, which you can see on this graph here on the right. Modern sea level is that dashed line. The beginning of this graph is 1.5 million years ago. And you can see all those oscillations on cycles all the way through that record. So during this time period, the Florida Peninsula, because of that broad carbonate platform shelf, Florida is just growing and then shrinking in size with each of these cycles, right? Roughly doubling in width and then shrinking to some unknown, some particular width and height out of the ocean. And all these oscillations have done some really important things for Florida, and it's sort of built the landscapes we know and love today when you're driving through the state. In particular, if you live in Florida or you visit Florida, you'll become familiar with the few pieces of high ground we have, right? The large ridges that run down the state, like the Pinellas Ridge runs down the center of the Pinellas Peninsula, or the Brooksville Ridge, right? If you've been to Withlacoochee State Forest, or even the Lake Wales Ridge, right, down the center of the state there. All of those big ridges that are upland environments now, those were formed basically as coastal dune type, island type environments when sea level was much, much higher. And they've been left there, sort of abandoned by the sea for now, right? More on that later. And as sea level has receded, those sort of paleo shorelines and paleo islands are still there, right? Great for agriculture, right? Citrus. So then we have sea level going back down at its the last glacial maximum around 20,000 years ago. We have sort of the maximum exposure of the shelf off of Florida. This is a model of that on the left. A large view, you can see the large glaciers covering quite a bit of the continental U.S. And you can see Florida is about twice as wide as it is now. So here's a nicer drawing. If you see that area in that light blue, that would have been about Florida's landform size during the last glacial maximum 20,000 years ago. Basically because all that seawater was locked up in glaciers, put simply. Right. Now on this drawing, you can also see the area marked land in green. That's an approximation of Florida's size during the most recent time we had an interglacial period, right? Or a period between glacial periods where we have warming, like the present. The last time we had a climate interval like the present, sea level rose about that high, 125,000 years ago. It's about 8 meters above present, right? And then, of course, it dropped down to that large exposed shelf 20,000 years ago. Now, all of these swings in sea level and climate have created these interesting landforms and ridges in the state. They've also done a really important thing. They've carved the limestone, right? The limestone beneath us is not solid, right? Thankfully, it is a Swiss cheese block of holes and interconnected caverns that holds, importantly, our aquifer, right? The Floridan aquifer and more superficial aquifers, freshwater resources, right? That interconnect with our rivers and streams. And importantly for Tampa Bay, or importantly for us, and relevant to the next couple talks, this karst processes, we call it when limestone gets eroded like this. These karst processes created some rather large networks of holes and depressions in the Tampa Bay area, right, that eventually would become our estuary, Tampa Bay estuary. So, speaking of, here's Tampa Bay estuary in two forms. So, at the time, I need to pull my notes back up, sorry. So, if we'll go back to the last glacial maximum about 20,000 years ago, Tampa Bay was not a bay at all, right? It was quite far from the ocean. You can think about it as in the center of the Florida Peninsula at that time, right? The environment would have been arid, scrubby, very dry, and you can imagine open savannas, right? Now, the Tampa Bay Depression, the karst holes, right, in the ground, that was all here. But of course, there was no seawater, but it did support large freshwater wetlands, including a very large freshwater lake that's called Paleo Lake Edgar, named for a geologist involved in its study. And that large lake was flanked by a mosaic of different wetlands. You can imagine cypress swamps, marshes, wet prairies, things like that. Now, we know this because this map on the left, or this model on the left, this is showing depth to limestone bedrock in the bay. So the areas in cool colors are basically very deep holes in the limestone. And this large one here in the center of Middle Tampa Bay is what we call Paleo Lake Edgar. We know that supported a large freshwater lake. We know this also because it's been cored by the U.S. Geological Survey. So with great effort, they pulled this very long core from the middle of the bay, and they found these wonderfully preserved lake muds beneath the marine sediment. And they've been very well dated with carbon dating, and they've been very well studied in terms of what fossil pollen is preserved in the layers and other types of small organic indicators about the environment. And from detailed studies of these cores by the U.S. Geological Survey, we know that this lake system and its surrounding wetlands were able to persist in the Tampa Bay Depression even across very, very arid, harsh climate intervals of the late Pleistocene and of the deglacial period, when the rest of Florida would have been sort of exceptionally dry, and most of the other freshwater sources may have been very restricted. We know we have freshwater wetlands in the bay. Right. This is just a quick slide showing, to give you a better reference of some of these shorelines. On the right is a sea level curve starting during the last glacial maximum with sea level way down and rising all the way to about 8,000 years ago when it sort of starts to slow down. And this map here on the left shows different successive paleo shorelines starting around the last glacial maximum, right? For instance, here's a good example. This one here, around 14,000 years ago. This is an interesting inflection point where sea level sort of was rising, but not quite so fast. And we actually have really interesting, well-preserved coastal features like barrier islands, oyster reefs, and other estuarine-type environments preserved way offshore along this contour. And that's sort of a very interesting frontier for marine science and archaeology, right? To study those ancient environments that have been were flooded around 14,000 years ago, and to see if people were using them. Humans tend to like productive coastal environments, so I think the chances are good. But it's just a difficult place to work. Anyway, where it's a little bit easier to work, and where there are also, we know where people around this time period, is Tampa Bay estuary. Right. Oh, and I should mention, so at this point it's important to talk about that during this deglacial period, right, at least as early as 14,000 or so years ago, we know we have people living on the Florida Peninsula, probably somewhat widely distributed, right? These are some of the projectile points that are found preserved from those early time periods. These lower types are all found in the Tampa Bay area. Right. So I'll start to talk now a little bit about some of our recent work in Tampa Bay, and we've been taking lots of cores to study the ancient environment. One of the really interesting findings from our coring in the inshore areas of the bay, of where these stars are located on this map, is that we found out that these very, very ancient freshwater wetlands that were there during the Pleistocene weren't restricted to the center of the bay in the Paleo-Lake Edgar system. They were actually very widely distributed. Even all along the margins of the bay, we're finding old sinkholes that have been infilled with sediment, but when you get through all that sediment down to near the limestone, you'll find freshwater mud deposits from very, very ancient wetlands, and they were quite widespread. So we can imagine sort of the whole Tampa Bay estuary footprint supporting these important freshwater wetlands that were probably a very, very large oasis for ancient peoples on an otherwise very arid and savanna-like landform. And these are some of our cores from upper Tampa Bay. We found this pattern everywhere else. We have a star here, but down way deep, we have these, to me, they're beautiful from a geological angle, right? So these beautiful freshwater muds, right? You find this and it's joyous because sediment deposits like this have great preservation of botanical remains. You can carbon date them. They're very informative. Now, as sea levels are rising across that deglacial period, the environment in Tampa Bay estuary is changing, and because as sea level rises, it pushes up the aquifer, right? So we have lots of freshwater springs come online, pumping that fresh aquifer water out into the estuary system, or into the depression, the freshwater wetland depression. And we see signatures for this in our sediment cores, where I have them pointed out here. These are these like very, very clean white sands with little bits of carbonate in them. And elsewhere, we find these very interesting thick deposits of freshwater snail shells. And by sort of looking between these different sedimentary signatures, we know that Tampa Bay, the areas that are now inshore Tampa Bay, supported these spring-fed, very clear water, what we'd call oligotrophic stream environments, feeding the Lake Edgar system. And this is interesting from an environmental perspective because today we have what are called blackwater streams that are tannic, the water is brown, full of tannins, light penetration is not so good. These streams are very, very different. These are just clear-watered, spring-fed streams, so sort of a very different environment. Now, all across this deglacial process, we have, of course, people living all along the margins of these wetlands. The trick is, all of those land areas that would have been ideal for settlement are now under the ocean, right? They're under the bay surface, and they're also buried in sand and mud and whatnot. So investigating them, even finding them, is quite difficult. And that's because, of course, sea level continued to rise, right? And around the middle Holocene, so between about 7,500 years ago and 4,000-ish years ago, we have a major environmental change in the bay, right? Around 7,500 years ago, the Gulf of Mexico pushes into the mouth of the bay. And Paleo Lake Edgar is no longer a lake, right? It becomes brackish and connected to the ocean. It's now an estuary. And one of the really, and we have good records for that, off of cores from Middle Tampa Bay and cores from off Ballast Point, done by USGS, found this out, finding really well-dated sequences of estuary transition around 7,500 years ago. Now, some of our work, all at these other locations that are starred around the margins of the bay, we were surprised because we have this estuary transition where we have those freshwater clear stream environments transitioning into tidal marsh, brackish tidal marsh, which leaves a really, really obvious sedimentary signature you can see here, basically these black sandy peats, sometimes with estuarine snail fossils or bivalve fossils. And what was particularly striking for us was that the transition to estuarine conditions in the margins of the bay, even up in Safety Harbor Basin, happened almost simultaneously with the transition in the middle part of the bay, which is really kind of strange. In a typical estuarine sequence where you have a flooded river valley system, it would be a very smooth, progressive flooding of the estuary spatially. But in Tampa Bay, we have a different story of basically very rapid conversion to the estuarine conditions because the whole system is connected together by holes in the limestone, right? All of these underground hydraulic connections could basically, even though the ocean had just pushed into the bay, even up in the Safety Harbor Basin, we have brackish conditions. So it's an interesting case. Now, of course, the human population of the Gulf Coast and the Tampa Bay region responded to this estuarine transition markedly. And at this time, we have really solid archaeological indications for ancestral Native American societies developing sophisticated maritime societies, right, or adaptations to the environment. This is when we see pottery being innovated as a widespread technology. This is when we see marine shell tools become commonplace. There's a very dramatic proliferation in the different types of projectile points. And of course, this is when we start finding the region's first, earliest preserved shell mounds, right? Archaic period shell mounds are not super common on the Gulf Coast, but they are around and they indicate that around this time we have proliferation of maritime adaptations. In Tampa Bay, Archaic period or Middle Holocene period shell mounds are not very common, at least not anymore. And during our work, we found sort of a limited number of deposits that date to this time period, and they tend to be buried down deep under marsh peat or mangrove peat. So the case probably is, like with the earlier sites, they are probably just at lower elevation, right? And they've either been flooded by the bay or they're buried under tidal wetlands, right? What's fortunate, though, is that because Tampa Bay is such a large and protected environment, right? It's not exposed to the open Gulf of Mexico, wave energy and storm energy, that we actually have a really good chance for well-preserved archaeological sites of these early periods submerged beneath the bay bottom, right? They're just a little difficult to study. So my last major, big change, geological change for the bay happened around 2,000 years ago, right? Those brackish tidal marshes, they lasted a long time, right? And for that Middle Holocene period, you can imagine most of the bay that's less than 6 feet deep would have at that time just been tidal marsh, salt marsh creek type environments, much like you'd get in Crystal River or Homosassa, what have you. But around 2,000 years ago, that changed quite a bit. And those vast marsh environments, I think because of basically another slowdown in sea level rise, we have a conversion of all those marshes into open seagrass meadows, much like we have today, right? If you paddle out in the bay, you'll have expansive tidal flats with seagrasses. Those environments don't seem to have really set up until about 2,000 years ago. Now, in response, they look like this in our sediment cores. You can see this sediment column here, these like laminated sands, right, with sort of diagnostic marine fossils for the seagrass environment. And what's striking is that all around the bay where we've worked in the inshore, this sequence occurs and it dates to the same time period, right around 2,000 years ago. And around the same time, this is when we have a sort of a fluorescence, if you will, of Native American fisheries in the Tampa Bay area, leading to the creation of lots and lots of native settlements near the present-day shoreline, what we'd call recognizable for what we call shell middens or shell mounds, which just attest to the shell fishery use and settlement on the coast. These are just some artistic renderings of what some of these coastal villages may have looked like. And then on the right, I just have some common artifacts. Of course, a very, very common, during this transition, the principal shellfish remain at these sites is oyster, and many of these oysters are quite large. Jamie, I'm sure will talk about that. And these are some of the very common shell tools we find, basically gastropods, crown conchs, or fighting conchs that have been hafted into a tool, likely for processing oyster. And then, of course, we have widespread use of pottery at all of these common era shell mounds. So this is where I'll drop you off to Jamie, who's going to pick us up with Native American fisheries in Tampa Bay.
All right, thank you, Kendall. And let's continue our conversation about coasts. Sorry. All right. So for much of archaeology's history, coasts were kind of paradoxically seen as so resource-rich that they did not require any sort of management, but not so quite, not so bountiful that they could sustain large populations or surplus production, characteristics that we more often associate with agricultural societies. Cultural change in coastal environments was explained simply by changes to the ocean or to the coast rather than, and really any sort of human changes to coastlines were kind of not even considered. But now this has changed. Archaeologists recognize the many ways that humans influence the environment. And one area where this is, the research is extensive is the Pacific Northwest. Here, First Nations peoples managed the landscape from the intertidal zone up into the alpine. This is a kind of a diagram of some of the coastal management systems. You see berry gardens and estuarine root gardens, clam gardens, fish traps, and I just want to quickly talk about clam gardens because I think they're just some of the coolest, most ingenious inventions ever. But clam gardens, I gotta raise this again, sorry. Yeah. Clams have this optimal zone of growth that's related to beach slope, and First Nations peoples recognized this, and what they did was line beaches with rocks to alter the slope. It filled in with sediment and became a bit flatter, and essentially the entire garden became optimal habitat for clams. So clams in clam gardens, they grow faster and larger, They're more bountiful compared to wild clam beds. So this was a way for First Nations to not only enhance their own food security, but the surrounding environment as well. And today, fisheries are a massive industry, and fisheries are this really complicated entanglement of biological and social and economic objectives, all related to the management of marine resources. And by management, I mean the actions taken towards achieving objectives, and that objective may be to acquire surplus or maximize biodiversity. There's a lot of objectives that people do related to fisheries management. And there's no single correct way to manage something, right? Because some things that benefit one species might be detrimental to another. So it's this kind of delicate balance to get everything right, but again, it boils down to kind of what you're trying to get out of it. And when anthropologists study coastal societies and the fisheries management systems within them, they tend to find some underlying similarities. And most societies have some form of harvesting regulations, tenure systems, and enhancement strategies. Now, fishers in the room are probably or hopefully familiar with harvesting regulations. These might relate to the size or season you can capture fish, maybe the gear you can kind of use. These vary depending on the species and where you are in Florida. Tenure systems are the rights and responsibilities to specific areas. There's kind of different levels to it. And one example that I find really interesting is the Maku system in pre-colonial Hawaii. And here, similar to the Pacific Northwest, people manage the landscape from the ocean all the way up to the mountaintops. And it's divided kind of by these different biomes horizontally that relate to elevational and rainfall gradients that lead to different ecosystems. But it's divided vertically by communities or the tenure or the access to communities. So if you're a community member, you're limited to acquire and manage resources to this specific vertical zone. And so that's a great, motivator to be a good manager because you're really dependent on that one specific area. And enhancement strategies are, basically infinite, but these can increase the availability or abundance of a specific species. Maybe there's a quality of a species you like that you want to enhance. Maybe it's making your fisheries system more resilient to climate change. There's a lot of things related to what you can enhance. An example from today is oyster farming, where farmers plant oyster seed in these bags that surf the waves. They get tumbled in these cylinders, and this is enhancing the appearance and taste of oysters, and they really stand out compared to their wild counterparts. So this is just one example of a way we can enhance something depending on what your goal is. We can also look to the past for enhancement strategies. Of course, clam gardens are another great example. But what archaeologists and anthropologists have also described are a lot of indigenous communities use what has been called eco-mimicry, or just human practices that kind of mirror ecosystem processes, like propagating plants or transplanting fish eggs, landscape burning, things like this that are probably happening at a large scale, but are very difficult to identify archaeologically because, again, they mirror ecosystem processes. Let's see. So, again, collectively, harvesting regulations, tenure systems, and enhancement strategies are common components of management systems worldwide. But when we think about why some are sustainable and why some aren't, we also need to look at the differences. And anthropologists typically find that differences in fisheries management systems are either based on the natural environment or social structure of the community, and or just ecological knowledge. And by ecological knowledge, I mean just generations of place-based ecosystem monitoring, generations of trial and error when it comes to kind of messing with fisheries and seeing what works, and all of this is just passed down to generation, so they really understand, the environment around them. A recent study by Atlas and colleagues compared traditional indigenous management with contemporary fisheries management in the Pacific Northwest, and this is related to salmon. And they find a lot of differences, but I just wanted to kind of highlight three. The first is that indigenous management systems are more place-based and more selective, meaning when they're fishing, they're usually fishing the same areas, and they're selecting from distinct populations and usually distinct fish within those populations, maybe the same size fish or the same aged fish. whereas contemporary fisheries are more mobile. They're targeting multiple populations and multiple age groups within that population. We can also consider the organizational structures. Contemporary fisheries tend to insert more kind of bureaucracy, more middle people in, and all of this, it just creates more space between the fishers and the people who are ultimately making management decisions. So there's more potential for disconnect. And then, it can also just boil down to motivation. Indigenous systems are focused on subsistence and are typically rooted in stewardship, where the contemporary management systems are trying to make a profit. And you may have noticed a few slides ago, I had that NOAA infographic, and it showed that salmon are the 4th highest value species in the United States at $478 billion. So it's a really huge industry. And these differences, of course, are, again, just related to salmon in the Pacific Northwest, and I just want to note that there's a lot of variability within both kinds of systems, traditional indigenous management and contemporary management as well. And when we look to the ancient past for information on fisheries, some of the best archaeological evidence are these fish capture structures, and that's because they're usually made out of rock and just survive the test of time, where a lot of fisheries management is kind of more difficult to identify in the archaeological record. So we have these fish capture structures. These are found worldwide on where every coastal society lived. You usually find these. But it wasn't really until recently that these were described in Florida. So here's 2 examples we have now. The one on the left is a tidal pool complex that is described by Ken Sassman and colleagues, and they have this fish trap where fish kind of migrate further in related to the tides, and this is just a way to kind of capture a lot of fish at once. And then on the right-hand side, this is Mound Key down in Estero Bay, that's capital of the Calusa. Victor Thompson and colleagues describe these water courts, which are these basketball-sized pools designed out of shell that would have held a lot of fish and potentially trapped them as well. But you might be able to trap fish elsewhere and then bring them to these ponds as a way to kind of acquire surplus, something, again, that's usually associated with agricultural societies. Now, do we have these kinds of things in Tampa Bay? The answer is kind of, I don't know, maybe. So when we think about where people decide to live and build villages here in Tampa Bay, what we see is they're often congregated near the mouths of rivers and tidal creeks and subbasins, all these limestone dips features that Kendall talked about. And these are kind of transitionary zones, sometimes called ecotones, where they're just known to be hotspots for fish. So we think these areas, the way they're placed, this is my rendition of a net, this yellow line. So just kind of put a net across site, and these are all sites. So sorry, the one on the left is down in Bishop Harbor in Terracea State Park. And then the one on the right is right here in the preserve, Ross and Gouge Island. And I kind of designed these little nets going from site to site just to show how kind of, how easy it would be to just place a net and capture a ton of fish. And I'm not just kind of making this up. The Spanish do describe these enclosures in Tampa Bay, these kind of great enclosures where they see, Native Americans harvesting a lot of fish, mass capture, and yeah. And so when we think about Kendall's dissertation research, which he kind of touched on, all of these landscape modification practices, all of this shell deposition is altering different ecologies. It's generating new ecologies in these subbasins. And so kind of these 2 factors relate to the tenure systems that I mentioned earlier, these rights and responsibilities. It's kind of easy to extend ancestral modification of land practices down to the descendants. And certainly, like the vibe you get from Spanish accounts seems like these areas are defended, which is another key characteristic of tenure systems. And beyond the ethnohistoric record, we're also employing a lot of archaeological techniques, ground-penetrating radar, mapping. These help get a feel for the site layout, potentially identifying any buried features. We're relying on excavations, usually 50 by 50 centimeter or 1 by 1 meter units. These are often in the intertidal zone, areas that are threatened by sea level rise and storms. We're also using material that's currently curated by the National Park Service and cultural resource management firms right here at the AWARE Research Station as well. So we feel it's important to kind of use collections when you can to help minimize any further impacts to the sites. And our excavations reveal just a number of sedimentary units, many kinds of cultural deposition, but also importantly, as Kendall highlighted, we're also working off sites where we want to see how oyster reefs are changing and wetland habitats are changing, because all of these are going to provide context on fisheries, what's available, what is around these villages in the first place. That's going to help kind of understand, how far people were going, and things like that. And when we're thinking about cultural shell deposition, we're also relying a lot not only on the variation in stratigraphy, but also radiocarbon dating, because radiocarbon dating is super important to contextualize any sustainability or fisheries impacts, because some shell features in Tampa Bay probably have billions of oysters, and I don't think it's not an exaggeration, like billions of oysters. And considering whether this is on a decadal or century scale, all of this matters to make any sort of argument whether there's impacts or sustainability. Time matters. The tempo of harvesting can mean a lot. And so our excavations, of course, are recovering a ton of animal bones, and as you can imagine, it takes some time to analyze all of these, even for specialists. So this work is ongoing, but we've identified over 40 different species so far, and most commonly they're catfish, mullet, drum, trout, stingrays, sharks. But really, their identification is kind of the starting point for so many more questions related to the fisheries. Because once we know what species are being caught, we can kind of think about their behavior. Do they swim alone? Do they school? These kinds of, what would be the most effective way to capture them? All of these kinds of questions matter. We can use the size of their bones to determine the overall size of the fish, which can also lead some insights into maybe the nets that we're capturing them, and also population structures, because how do fish change through time? This is all valuable information to contemporary estuary managers. And when we know how fish are being caught, we can begin to think about how people may have scheduled their days, because some fish species and shellfish species are best caught at the same time of year, at the same tide or time, and so you really would have had to make decisions on how to best divvy out tasks on what you wanted to accomplish that day. So we can start asking those questions. And it's important to think about all of these patterns within and between sites or through space and time, because some areas like Crystal River, we see that early on people are harvesting a lot of different species, and then as time goes on it gets narrower and narrower until towards the end they're only harvesting a few species. And so is this a specialization in the fisheries? Time will tell if we see similar patterns in Tampa Bay. And yeah, I just want to say, if you're out there and are good at identifying fish bones and thought any of those questions were interesting, please hit us up. But much of our work has currently been focused on the mollusks, or all of those shells. And so we've identified 50 species of shells, 200,000 individuals, and about 5,000 pounds. A lot of shell. And so yeah, similar to the fish, we want to examine how these change within and between sites to kind of highlight differences in the availability, or maybe how people were targeting different habitats. Generally, what we see is a bay-wide transition from oyster-dominant middens to kind of transitioning into a broader breadth of species. More gastropods become more prevalent at about 8,700 or so. And so here's just a quick comparison of 3 sites in Old Tampa Bay: Cabbage Head Bayou, Ross Island right here in the preserve, and Safety Harbor. And we can see just differences in the species compositions. Cabbage Head Bayou in the center is very oyster dominant. Some tests were like 98% oyster. And then you see the other 2 sites have a lot more variation, a lot more gastropods. And so this is going to help kind of think about different foraging techniques, or what was available around the site at the time, perhaps. When we're thinking about species compositions and where different species like to hang out, we can then kind of use techniques like these quantitative techniques like ordination to kind of predict where a lot of harvesting was taking place. So what you need to know to interpret this is just points that are closer together are more similar in species than those are further apart. So we can see Cabbage Head Bayou down at the bottom is tightly clustered. We know that because they're harvesting oyster reefs. But you see a lot more variability at Safety Harbor and Ross Island. And again, like the species compositions kind of show that people at Safety Harbor were usually targeting more mudflat-like environments, where people at Ross Island were targeting more sandy flats. So this just helps kind of think about mobility within the estuary, maybe the kinds of environments that were around the village and the different preferences of species and how they vary through space and time. And to provide some further context, we're also measuring a lot of oysters and a lot of gastropods, because this is further helping us understand different habitats and any potential impacts or sustainability. And what we see on the top one is, this is by site, we see oysters at Cabbage Head Bayou are a lot larger, and then gastropods at Ross Island are a bit smaller. When we kind of compile them by time period, we see oysters kind of shrink, and some of the gastropods get larger. So we're kind of piecing it all together, site by site, like kind of like a multi-scalar perspective, where you're kind of lumping and splitting a bunch of different sites and times and space, just to kind of see what kind of patterns we can draw out. At some sites, this is Cabbage Head Bayou, we see that near the bottom of the unit, there's these huge oysters, sometimes almost 20 centimeters, and towards the top, not so much. And so we're kind of piecing this together, is this people targeting the large oysters first and working their way to the smaller ones? Are they just leaving oysters alone because they recognize that those are some of the most significant oysters, to leave them alone? To the larger the oyster, the more ecosystem services they provide. Is this some sort of environmental shift that's leading to smaller oysters? We're still piecing that together, but I think there is some evidence for some sort of environmental shift taking place at this time that is potentially leading to kind of smaller oysters. And to provide some further context on environmental change, we're investigating the chemistry of the oyster shells. And so shells grow just like trees in rings or increments, and they like to live in equilibrium with the water. So the water chemistry is going to be the same as the shell chemistry as they grow. So as they grow a little increment by increment, they're recording the exact water conditions that they live through. And so we can use a drill, the same one your dentist uses to drill out cavities, we use to drill out little holes in the oyster, and we can track how the environment changed through the oyster's lifetime. And so an example is this middle figure that shows these peaks and dips. These are related to water temperature, and this helps us predict when oysters were being harvested. And then we also use different techniques, like this is a lasering technique at the bottom, where it kind of illuminates the different trace elements in the shell. So this can kind of further help answer questions related to like where people were gathering oysters. And so again, the goal here is to kind of get at those harvesting regulations and tenure systems. Were there seasonal restrictions to oyster harvesting, or, were certain oyster reefs reserved for feasting events? The good ones, right? Why would you not? And what kind of tools were used for harvesting them? Maybe the shell hammers that Kendall showed earlier. And how do these regulations differ from the way we manage oysters today? These are questions we're still working on, but generally, we see that oysters from mounds almost always show a kind of a cooler temperature signature, while those from middens or domestic kind of areas are more indicative of year-round collection. So it seems like there is a difference in the kinds of deposits. So we think that maybe restricting harvesting efforts for mound construction would be a good management technique. I'm not saying that's why mounds were, built in the winter, but the one potential consequence of that is that you're leaving oysters alone in the summer. That's when they reproduce, so you're kind of helping out further generations of oysters. That's also when water temperatures are high, that's also when there's a risk of more pathogens in the water, so you're avoiding that risk. But really, as Floridians, we know it's just better to meet when it's cooler out, right? So they have this kind of effect on, all these actions have different effects on fisheries management. And so we have a lot of data, and we're still piecing it all together, and I would probably have a lot more to say in another year or two. But so stay tuned, follow us, and we'll keep you updated. So now we've heard about the estuary's geological history and its fisheries, and I'll hand it off to Tom to talk about how the bay became a bay.
Thanks, Jamie, and thanks, Kendall, too. So, yeah, Kendall and Jamie have kind of laid the groundwork here. They've done a lot of the heavy lifting, how the bay was transformed over tens of thousands, in Kendall's case, millions of years, through geologic processes, but also through the agency of native peoples that were living in the bay and managing resources. So my task is to kind of wrap this up by talking about how the bay became Tampa Bay. And I mean that in a couple senses. I mean it, first of all, like, how did it become known as Tampa Bay, but also how was it transformed in the past 500 years of European and American settlement. And that's that second one is much too big to cover in 10 or 15 minutes. So I'm gonna kind of focus more on those resources that were particularly important that, the fish and the shellfish that they talked about. So, you know, I was giving a talk similar to this one a few months ago, and somebody asked a really good question that I hadn't really thought about. They asked if we knew what the native peoples of Tampa Bay called the bay, if there was a word for Tampa Bay. And like I said, I hadn't really thought about it, but as far as we know, or we don't know, is actually what I should say. What we do know is that native towns in Tampa Bay and throughout the Southeast took their names from the chiefs of the town. And it's possible that the bays also took the name from the chief, and there's some evidence for that we'll see in a second. So we know, for example, from the earliest Spanish expeditions, Pánfilo de Narváez in 1528 and Hernando de Soto in 1539, both landed in Tampa Bay. And de Soto in particular names a couple towns in Tampa Bay. He landed on the south side of the bay, spent some time in a town called Osita, and then moved through or around a town called Mocoso. You'll notice, though, there are no towns that they described that were called Tampa, right? So the first record we have of Tampa as a place name comes from, and this is there's several fascinating stories like this in Florida colonial history. From the 1550s, this was Escalante de Fontaneda was a Colombian-born Spaniard, so he had never been to Spain before. He was traveling to Spain by ship in his teens, and he was shipwrecked in the Keys. And he lived for something like 20 years as a captive of native peoples in Florida. And when he got back to Spain, he wrote a memoir, and he describes some places in Tampa, or in Florida, and he describes some native peoples of Florida. So it's a really valuable record. But you'll see I have highlighted, spelled slightly differently, but that's an English translation. He mentions Tampa as one of about 25 towns on the West Coast. The thing is, though, that Fontaneda listed the towns from north to south. And judging from that, and judging by later sources, Tampa was not in Tampa Bay. We're pretty confident now that Tampa was to the south of Tampa Bay around Charlotte Harbor. Now, native peoples moved around a lot after the Spanish and in the colonial period because of the pressure from European colonialism. And it's possible that the people who called themselves Tampa moved into the bay, but we don't have any record of that. There's no record, really, that the people who called themselves Tampa ever lived in Tampa Bay. Now, Fontaneda did mention one town in Tampa Bay that's Tocobaga. And we're pretty confident, we've been confident, archaeologists have known for a while, that it was probably represented by the Safety Harbor archaeological site, which is up in Old Tampa Bay, right outside the modern town of Safety Harbor in Philippi Park. And we can say that because Fontaneda described the location of Tocobaga as being at the back of the bay, at the very kind of end of the bay. Near the chief's house was near the water. And if you've been to Philippi Park, the mound is right next to the water. The chief would have lived on top of the mound. The location just almost perfectly matches the Spanish descriptions of Tocobaga. And other archaeologists, but we recently have done archaeology in the park, and we can't prove it's Tocobaga, but there's Spanish pottery there. There's, of course, Native American pottery there. The native town was established around 1200 AD and was still there when the Spanish came. And we do have radiocarbon dates on charcoal that would indicate that it's the right time period. So the Spanish established the Spanish established a mission at Tocobaga in 1568, but it didn't last long. The Spanish governor, Pedro Menendez de Aviles, came. He left 30 Spanish soldiers. They built a little mission fort. But he went back to the main mission that was to the south. They started getting reports that there were trouble at this mission. The Tocobaga were fiercely resistant to Christianity. It rained a whole bunch, so there might have been a hurricane, but all the food stores got wet. And the Spanish were starting to abuse the native peoples. So about a year after the mission was established, the Spanish came back and found all the Spanish soldiers had been killed, and so the Spanish burned the town in retaliation. So, rightfully though, Tampa Bay should be known as the Bay of Tocobaga rather than Tampa Bay, right? And that is actually how the Spanish called it for a time in the late 1500s and 1600s. This is not an easy map to read, and it's got a weird orientation. I've reoriented on the right, but you can see Bay of Carlos. Carlos was the chief of the Calusa. That's the southernmost one. Go one bay up. That's probably Tampa, but it wasn't labeled. And then the next bay up is the Bay of Tocobaga, and that's probably Tampa Bay, right? So the Spanish knew. They called it the Bay of Bahia de Tocobaga, Bay of Tocobaga. Here's another one that's not easy to read, but it says Bay of Carlos again. This one actually says Bay of Tocobaga around Charlotte Harbor. And then the bigger bay, they call it Bay of St. Joseph. And, this is one of my points, I guess. The Spanish were just confused most of the time by native place names, and they mixed them up, and it's very hard to sort through. You may ask what happened to the Tocobaga. They lived for a while longer in Tampa Bay after the Spanish burned their town. Eventually they moved north and were settled on kind of the fringes of the Spanish missions in northern Florida. They never embraced Christianity. The Spanish complained about them a lot. Eventually they were wiped out by a rival native group. And you can see on this map up at the top left, it says Tocobaga Indians destroyed 1709. That's about the same time that the Spanish missions in northern Florida were destroyed by English and Creek and Yamasee Indians that came down. And for a while, Spain didn't give up Florida, but they kind of became less interested in Florida for a while after the mission system collapsed. But when the French started building New Orleans, the Spanish got more interested in Florida again, and they reestablished Pensacola. And the French kept making inroads, though. They mapped the Suwannee River, and the Spanish started saying, okay, we better kind of, assert our claim a little bit more. So they sent several expeditions in the mid-1700s, and this is one of Francisco Maria Celli. It's said to be the earliest detailed map of Tampa Bay. And Paul has brought a colorized copy here that's up front that people could look at afterwards. But it's a super detailed map of the bay itself. And you can see that he does call it Tampa Bay, although he also tries to rename it San Fernando, in honor of the Spanish king. He basically tries to rename almost every feature in the bay. But it's an interesting map. And he did have some contact with the native people. He barely went on shore, and if you notice from the map, there's not much detail on the river because they pretty much stayed on the boat. But the native peoples came to them and swam out to the boat. And there's some interesting detail. This was the Enlightenment, so they were mapping the bay, but they were also kind of curious about native people and also native flora and fauna. So I think it's really interesting to look at the margins of the map, because you see I don't know how well you can see it, but he does draw native people doing things. He's got people cooking over a fire, some people sitting and eating. There's some people sitting next to a mound, probably a shell mound like Jamie was just talking about. And then he sees what looks like, to me, native people kind of burning some timber, and I think they're probably burning off fields to plant crops even, perhaps. Another reminder that this is a landscape that had been, actively managed by native peoples well before Europeans came. And then here's some descriptions of some of the animals he saw around Tampa Bay. At the top left, you'll see Bajos de Ostianos, which is oyster bars right at the mouth of Hillsborough River. He's got a turkey, maybe a quail or a pheasant, I can't tell, some kind of bovine. And then you'll see alligators, snakes, something that looks like a panther, kind of fanciful depictions of them. So in 1763, the Spanish ceded Florida to the British. And so we have some British maps from that period that show Tampa Bay. This one is probably based directly off Sealy's. You can see though, he comes back to calling it, and I neglected to mention, De Soto, when he came, he landed in Tampa Bay on a Spanish holiday that was the Feast of the Holy Spirit. So he called the bay Bahia de Espiritu Santo, or Bay of the Holy Spirit. And so that name kind of stuck with the bay for a long time too. They intermittently referred to it as Tocobaga Bay, Tampa Bay, Bay of the Holy Spirit. So the British are using the Spanish name Espiritu Santo, and what they do is they reserve Tampa Bay for Old Tampa Bay. You can see up in the smaller embayment called Tampa Bay, it says Tampa Bay according to the Spanish. This is another British map from this interval. This is by Bernard Romans. And you can see he's starting to call the whole bay Tampa Bay, but it's not consistent. He lists both, Espiritu Santo and Tampa Bay. And here's where we start to get some text descriptions of some of the resources in the bay. He talks about, what a great harbor it is. He talks some, I don't have the quote here, but he talks some about how many fishes there are in the bay. And it's also interesting to note at that point of land up at the top where the city of Tampa will eventually be established, it's called Circlo or Buffalo Point. And he doesn't elaborate on that, but he does mention, see where he has the Manatee River, which actually looks like it's probably the Alafaya, but he mentions seeing buffalo tracks on the Manatee, what we would know as the Alafaya. You've probably heard about buffalo up at Paynes Prairie. Most people don't know that it seems like buffalo had extended even as far south as Tampa Bay in the 1700s, at least in small numbers. So I've got a couple more maps just to show you the progression of names. So here we have now, the British are still using the term Espiritu Santo for the bay as a whole, but you can see Tampa Bay is Old Tampa Bay, and here we're also calling Hillsborough Bay as we know it today. And that was named after the Earl of Hillsborough, a British nobility. In 1783, Spain ceded Florida back. British ceded Florida back to the Spanish. They still didn't do much with the Florida Peninsula. They did send a couple expeditions to map, and they kind of flirted with the idea of establishing a stronger port in Tampa Bay. So they mapped it a couple more times, and there are a couple more descriptions of the resources here. This is one, Vicente Fulci Juan, who had a terrible time mapping the bay. He just describes, waiting around in the muck trying to map the margins of the bay. But he did recognize it as a good port with substantial fish resources. Now, Spain's, because they never established a permanent settlement on the Gulf, their hold of the peninsula was always kind of tenuous. And after American independence, they ceded Florida, the rest of Florida, to the United States. The fact that they didn't have more of a presence here had opened up opportunities for escaped slaves and Native Americans from elsewhere in the United States, the southern states that were under pressure from the United States government, to flee south into Florida. It provided a safe haven for them. And so this is on the window of more American settlement in Tampa Bay. This is a report to the Army about the Native groups that are living in Tampa Bay in 1820. And you can see there's a dozen towns of thriving in Tampa Bay. These were mostly, Creek immigrants that were mixing with the remnants of native Florida populations, and they were starting to be referred to as Seminole and Miccosukee. I won't go into much detail here, but one family was kind of at the wrong place at the wrong time. The Hackley family, Hackley was the U.S. consul to Spain, and he had gotten a grant from the Spanish Duke or he had bought 12 million acres in Florida, including Tampa Bay. But he bought it right before the land transferred from Spain to the United States. And the treaty that established that nullified all the claims that were made to Spain, right? So Hackley, though, refused to abide by this, and he sent some surveyors to record at Tampa Bay, and we're fortunate that he did put up this struggle. It was not successful. His family took it all the way to the Supreme Court and lost eventually. But he did send this SS Seymour down to do a survey of the bay, and Seymour provides a glowing account of the resources in Tampa Bay, describes, oyster, fish, just in apparently exhaustless quantities. Apparently is key, though, because we will find out that they were exhaustible. So this was, Hackley established a little settlement in Tampa Bay, built a house, but the United States needed to establish a military fort because we had just signed a treaty with the Seminole. They granted them a bunch of land, but we wanted to keep an eye on them, and we also had ulterior motives of eventually trying to force them out of Florida, right? So Hackley's son was living in Tampa Bay, but he left to go somewhere, and while he was gone, the military moved in and took his house and established Fort Brooke in Tampa Bay. And so we have some really good records from soldiers at Fort Brooke that talk about the native flora and fauna in Tampa Bay. One of the best is this guy, George McCall, who was an avid outdoorsman. And you can see he talks about how marvelous the fishing was. He talks about this being the finest oyster ground on the continent, that he's never eaten oysters like this anywhere. Here's another one. This is actually an English soldier that was fighting for the United States, George Ballantyne, and he talks about shellfish in inexhaustible quantities. I'll skip that one. But, the thing is that, of course, you should never call a quantity of natural resources inexhaustible, because they're all exhaustible. And so as Tampa grew up around Fort Brooke and the population increased, there started to be more pressure on these resources. And we have a nice record of that from this gentleman, H.A. Smeltz, Smeltz had actually come to the west coast of Florida in 1876, and he had been just blown away by all the oysters on the west coast of Florida. He described it as oysters, oysters everywhere. But when he comes back in 1898, he notices every bar is being depleted. Now, you can't read this, but I'm going to tell you it's from the City of Tampa archives, and it talks about the city passing a law that you have to take your trash a mile out of town and burn or bury it. And then there's another part of the law that says you have to go a mile outside of the city limits if you're going to deposit a dead animal into the Hillsborough River. Now, the fact that they had to pass a law of this means that it was already becoming a problem, right? So, you know, Smeltz is probably right that the bars are starting to be depleted, but there are indications that the oysters are hanging on, that they're resilient for a while. If you'll see on the right, it sounds like a good headline, Bay oysters are pronounced pure, but if you read the text of the article a little closer, you see that somebody died eating oysters. And you'll also see that they died because they harvested oysters that were coming from Hillsborough Bay, where the sewage of Tampa was just being dumped untreated, right? Now, they're still going, though, because you'll see at the top left, well, this is from 1894, you'll see that oysters were being sold for incredibly cheap prices, and you can buy them at all time of the day and night. And you also see that they were being exported. So this is from a hotel in Valdosta, Georgia, advertising their Christmas Eve dinner that has Tampa Bay oysters Imperial. But as the article on the right shows, by 1928, things are starting to go south for oysters in Tampa Bay. And, you know, the continued history of Tampa Bay is just one of more and more degradation of the environment. We're all familiar with the Piney Point disaster that happened a little while ago. We happened to be working very near Piney Point when that came. We had to evacuate our equipment out of Bishop Harbor. But that was not the first spill in Bishop Harbor. When the phosphate companies started mining some of that deep limestone that Kendall was talking about, they spilled in the 1950s, they spilled phosphate waste into Bishop Harbor, and the harbor was pronounced biologically dead for a while. So I guess if there's a wrap up here, oh, and I was also just quickly, not only have Americans and Europeans extracted live oysters, but they've also extracted the remains of the oysters from the Native American sites. So, you know, as Tampa started to grow, as St. Pete started to grow, they needed to build roads, and they turned to the Native American shell mounds as road fill material. The shell provided good traction. So you can see on the left an ad from the Tampa, or a story from the Tampa newspaper where the city council is buying shell mounds to mine shell for roads. And these were major kind of engineering efforts. Look on the right, this is not from Tampa Bay, but this is from Punta Rasa, where they were mining shell from an island, and they built a narrow gauge railroad to haul the shell across the river so they could use it for road fill. And so, you know, what we used to have in Tampa Bay, the landscape used to include huge shell mounds, 30, 40 feet tall, hundreds of feet long. And already by the early 1900s, some of these had been reduced to nothing. Even in downtown Tampa, Fort Brooke was built around a shell mound. Soldiers that were stationed there mapped the shell mound. There was a pagoda on the top. It was a nice little garden feature. But that is no longer, of course. It would have been right near Amalie Arena. This is kind of an artist's rendering of what it would look like if it was still around today. A lot of people might be more familiar here over in St. Pete with the Shell Mound Hospital. This one survived quite a while. Bob Austinson here, who's an expert on this one, but survived into the 20th century before it was mined away. So this is not my slide, but if I was going to wrap it up, I'd say, you know, we've seen that this landscape of Tampa Bay is one that has been managed by people for 10,000 years now. But there was an inflection point that took place around 500 years ago when Europeans came onto the scene. And Jamie talked about management and different types of management, and some being more extractive. And what we've seen is the effects of a much more extractive sort of management program that's taken hold. This is not to say that Native Americans didn't, sometimes over-harvest resources. We think we have evidence that at some points they might have put too much pressure on the oyster population in Tampa Bay, but it was nothing like what happened when Europeans started moving in and extracting fish and shellfish from the bay. And, I don't know, I'm trying to end on a more positive note. These things are cyclical. We'll never get back to what was here, but we can manage them better than we have in the past. So, thank you on behalf of my